The seventh continent on the DAC, secluded underside of our planet, we find its most unforgiving alien continent, Antarctica, a frozen desert larger than Europe, lying atop a massive slab of more than 90% of the world's ice. Around its towering cliffs and coastlines, life flourishes unabated, from birds and plants to deep-sea creatures. On the inside, however, the conditions are so extreme that hardly anything more than microbe can prevail. But buried beneath its barren surface, lie fossils and relics from a bygone age when Antarctica looked wildly different, covered, not by ice, but by forests of trees, home to all manner of prehistoric creatures. Today, that world is gone, lost under several kilometers of immovable ice. But thanks to the pioneering technological advancements of the last century, we've managed to unravel its frozen layers and reveal the continent's hidden past, how it transformed from a once rich, temperate oasis of early life into the largest desert on the planet, Antarctica. Nestled on the South Pole, often in perpetual darkness, Antarctica is a shadowy no-man's land of the Earth. It is the only continent with no permanent human habitation, in contrast to the Arctic, where many communities thrive in the countries within its perimeter. But unlike the Arctic Circle, which is an ocean surrounded by land, Antarctica is land surrounded by an ocean, rendering it much more isolated and inaccessible. As such, it is the only continent with no countries, and while some nations lay claim to pie-shaped slices of its territory, these claims are meaningless without human settlement to back them up. But on Antarctica, during its winter months, especially, conditions are simply too harsh to accommodate prosperous life. On the contrary, most of its endemic species are extremophiles, like bacteria, fungi, moss, and lichen, which have evolved over millions of years to tolerate extreme cold, little sunlight, and constant lack of liquid water properties which make them compelling analogs for the blueprints of life on Mars. In contrast, complex life is much more prevalent around the coastal areas of Antarctica, from its myriad iconic penguin species to the fearsome 3-meter leopard seals that hunt them, as well as more than 100 million birds that nest here during the spring. Meanwhile, the oceans surrounding Antarctica are as brimming with diverse life, as its interior is desolate and deserted, thanks to interactions playing out within the Antarctic Ocean, which covers the bottom fifth of the southern hemisphere. The Southern Ocean is defined along the boundary where warm water currents from the Atlantic, Pacific, and Indian Oceans meet the freezing cold flows washing up from Antarctica. When this happens, complicated interactions between the currents and Earth rotation cause the deepest, most nutrient-rich water to rise, in a process known as upwelling, fueling seasonal phytoplankton blooms, which form the basis of the continent's vast marine food web, from shellfish and spiders to octopuses and colossal squid, orca, fin, humpback, and sperm whales, and even the planet's largest creature, the blue whale. Furthermore, this Antarctic upwelling plays an outsized role in maintaining the global balance of our planet's oceans, forming a conveyor belt along the Southern Ocean's boundary, which circles warm water round the globe courtesy of the Antarctic Circumpolar Current, the strongest of its kind on Earth. But this so-called west wing drift also acts as a moat around the fortress Antarctica, lining the surrounding seas with a circumpolar storm track that keeps the land locked in a vortex of bitingly cold wind, far harsher than anything felt in the Arctic. Around the North Pole, temperatures can fall as low as minus 40 degrees Celsius, but in Antarctica, they average closer to minus 60 degrees Celsius. The lowest temperature ever recorded on Earth, of minus 89.2 degrees Celsius, was measured in the depths of the Antarctic desert by the Soviets' Vostok station in 1983. And in 2010, an even lower temperature of minus 93.2 degrees Celsius was picked up by a satellite. The great ice sheet such temperatures render the overwhelming majority of water in Antarctica frozen as hard as rock, allowing tens of millions of years' worth of precipitation to accumulate here, blanketing more than 98% of the continent's underlying landmass with a great sheet of freshwater ice standing taller than many of its mountain ranges. With an average thickness of some 2 kilometers, but rising to almost 5 in some places, this ice sheet elevates Antarctica to be the highest continent on Earth, as well as the driest and least accessible. Locked within is more than 2/3 of all the fresh water that exists on Earth, enough to raise sea levels by more than 50 meters worldwide if returned to liquid form. Without any ice at all, Antarctica would appear as a continent of two tectonic halves. It's east a vast, mostly flat plain the size of Australia, bordered by a handful of relatively young, mountainous archipelagos and volcanic island chains in the west, formed by the same tectonic processes that sculpted the 7 continents. West Antarctica, the uppermost of these landmasses, lying only 1,000 kilometers from the underside of South America, is the Antarctic Peninsula and surrounding islands, one of the mildest, most accessible environments in the whole continent. This far from the South Pole, temperatures can climb above freezing in the summer, rendering it a biodiversity hotspot and the focus of several important research efforts studying Antarctic biology and climate. Examples include the U.S.-administered Palmer Station, the U.K.'s Rothera Research Facility, and Argentina's Base Esperanza, the birthplace of the first-ever native Antarctic citizen in 1978, Emilio Palmer. But what really makes this stretch of West Antarctica so intriguing is its mountains. Mountain ranges are formed by colossal tectonic processes occurring deep below the Earth's surface, and these mountains bear striking resemblance to those of the southern Andes, lying just the other side of the Drake Passage. Their geological likeness and similar ages imply they were once part of the same mountain range, and that the Antarctic Peninsula is an estranged extension of South America. Moreover, on the opposite side of the peninsula, near its base, we find the Ellsworth-Whitmore terrain, home to Antarctica's tallest peak, Vinson Massif, standing some 4,900 meters. It lies within a range which also shares geological similarities, this time with the Cape Fold belt running through South Africa, strongly implying a physical link between these 3 disparate continents in the past. To that end, even more eyebrow-raising geological evidence can be found in the east of East Antarctica, the vast, elevated plateau and desert, lying atop a much older, larger block of stable continental crust. Though hardly anything other than microbes can survive its conditions today, the surrounding mountains left peeking above its icy surface have turned up fossils from an age when life was much more prevalent on the plains of East Antarctica. To its north, we find Queen Maud Land, a mountainous 2.6 million square kilometers stretch claimed by Norway. Many of its rocks are more than 1.2 billion years in age, also sharing properties with those in Africa and India, once again reinforcing an ancient geological link between these remote continents today. On the south side of East Antarctica, meanwhile, lies one of Earth's longest mountain chains, the Transantarctic Range, with peaks of more than 4,500 meters. Mount Kirkpatrick of the Queen Alexandra Range is one such peak. Its relative lack of an icy covering renders its rock much easier to excavate, and that's how in 1991, scientists chanced upon a graveyard filled with the bones of an unlikely Antarctic inhabitant in the past, the dinosaurs. The Hansen Formation is one of the most important fossil sites on the entire planet, turning up a plethora of dinosaur fragments from the early Jurassic period, all of which belong to species apparently unique to the Antarctic continent. But none of these creatures would have found their way into the East Antarctic bedrock if it had been frozen on the South Pole for the longest time. On the contrary, these dinosaurs would have roamed Antarctica when it was unglaciated and lying in a much more promising position on the young Earth sandwich between Africa, India, and South America in a sprawling prehistoric supercontinent known as Gondwana. Around half Gondwana, Antarctica's past 1 billion years ago, Gondwana had unified much of the land in the modern-day southern hemisphere, including all of Africa, South America and Australia, India and Madagascar, and finally, Antarctica, all in a single landmass spanning more than 100 million square kilometers. Within the bounds of this ancient megacontinent, both sides of East Antarctica would have been sutured to Africa and Australia, while the younger, more tectonically active amalgamation of land making up West Antarctica was adjacent to South America. And much like those continents today, ancient Antarctica would have been covered with dense forests, home to a wide variety of prehistoric flora and fauna, many of which show up in Antarctica's fossil record. On the northern side of the Queen Alexandra Range, early explorers of Antarctica unearthed the fossilized remains of bizarre, fern-like plants whose leaves were strewn with seeds. They belong to an extinct variety of exotic early tree known as Glossopteris, which once stood prominently across the continent, and whose fossils can also be found in Africa and India. This game-changing discovery provided yet more empirical evidence for the contemporary 20th century theory of continental drift, along with the staggering revelation that Antarctica was once home to an oasis of life covered by a fern-conifer ecosystem it inherited from its neighbors. But these idyllic conditions wouldn't last, because 180 million years ago, Gondwana was breaking apart from within as plumes of magma beneath the surface weakened its continental crust. In the 100 million years that followed, East Antarctica began sliding apart from both Africa, India, and Australia, dragging its west side away from the tip of South America in the process, and opening the Drake Passage between them. By about 50 million years ago, Antarctica was free of its neighbors and drifting over the South Pole. But this isolated the continent further as it became entrenched in a polar vortex, causing temperatures to plummet, along with the amount of daylight, access to liquid water, and overall abundance of life. By 30 million years ago, Antarctica's once-rich forests and jungles have been reduced to dry tundra and shrubbery, and its biosphere pruned to extremophile species such as moss, algae, and fungi. And by 17 million years ago, the frozen precipitation accrued in its mountain valleys had glaciated, catalyzing the formation of the Antarctic ice sheet, which buried the continent's once illustrious biosphere beneath layer upon layer of solid ice. Just imagine the kind of fossils we could unearth and the secrets we could uncover if we were able to excavate beneath this great natural barrier shrouding the continent today. Ross Island, the Beardmore Glacier, where many of these ancient fossils were found, lies on the southeast side of Queen Alexandra Range, which stretches about 200 kilometers into the Ross Ice Shelf, a France-sized floating glacial platform that is the largest of its kind. On its fringe, we encounter yet another fascinating jewel of Antarctica, Ross Island. Discovered in 1841, this massive volcanic island lying at the base of the Transantarctic Mountain serves as a natural gateway to the South Pole, which early 20th century explorers scaled to gain access to the East Antarctic Plateau. During the so-called heroic age of the early 1900s, a number of daring, perilous voyages to both our planet's poles were undertaken by various explorers, many of them using Ross Island as a key strategic stepping stone. Between 1901 and 1904, race to the South Pole, the British National Antarctic Expedition Discovery saw decorated naval officer Robert Falcon Scott reach the furthest point south ever recorded, alongside Ernest Shackleton. They landed at the foot of what was then known as the Great Ice Barrier, aka the Ross Ice Shelf, and established a hut-like base on Ross Island for supporting future expeditions. Years later, and these two former crewmates would each embark on their own ill-fated voyages aiming to be the first to reach the South Pole. In 1908, Shackleton moved first when he landed his ship Nimrod at Cape Royds, setting out on an ambitious sledding mission which took him deep into the Antarctic wilderness. He and his 3 companions came painstakingly close to reaching the South Pole, but were ultimately forced to abandon their mission with 180 kilometers to go due to lack of further supplies and sheer physical exhaustion. In the words of Shackleton himself, "A live donkey is better than a dead lion." His former captain-turned-competitor, Robert Falcon Scott, would soon come to rue these very words as he set out on his own expedition to the South Pole, Terra Nova, 3 years later. His party ascended Ross Island on the 1st of November, 1911, unaware that Norwegian explorer Roald Amundsen had already departed the Axel Heiberg Glacier in the previous month. And unlike Scott's team, who carried out research along the way as they attempted most of the journey on foot, Amundsen's team fast-tracked their progress with an intuitive mix of dog sledding and skiing, allowing them to cover more than 65 kilometers a day. They arrived at the South Pole on the 14th of December that same year, comfortably beating Scott's team, who arrived battered, bruised, and malnourished on the 17th of January 1912, only to discover that they had been beaten, courtesy of Norwegian flag and letter left behind by Amundsen. Scott's diary entry that day makes for harrowing reading, and he continued writing heartfelt and gut-wrenching passages until only shortly before his death in late March, when he and his remaining crewmates perished in the throes of an Antarctic blizzard. In the century that has followed the Little America base's race to the South Pole, our understanding of Antarctica has drastically improved, thanks to advancements in flight, radar, aerial photography, and echolocation. These tools have delivered unparalleled insights into the continent's once elusive geography and topography, even turning up hidden mountain ranges submerged beneath the icy surface. Most of these innovations were pioneered after the First World War, as the United States took over as a primary stakeholder in Antarctic exploration, backed by their sizable Air Force and Navy. Between 1929 and 1958, they executed a series of complex, multi-pronged reconnaissance missions aimed at mapping Antarctica's surface and identifying locations for its Little America research bases, each responsible for a number of Antarctic firsts during their operation. In 1934, Little America 2 was the first base to broadcast detectable radio signals to the U.S. mainland from a distance of more than 18,000 kilometers. For Little America 4 in 1946, no less than 25 aircraft and 13 Navy ships snapped more than 49,000 photographs of the continent. And Little America V, established January 1956, was one of 7 Antarctic bases built by the U.S. for the International Geophysical Year, a broadened global scientific cohesion and collaboration. Another of these bases was McMurdo, which has remained the primary logistical outpost of U.S. Antarctic operations ever since. McMurdo Station is the largest base in Antarctica, located just off Ross Island at the gateway to the South Pole. This miniature city, comprised of more than 80 buildings, can hold up to 1,250 people at a given time, with research labs, repair facilities, libraries, gyms, stores, coffee shops, and all manner of other amenities on site. Around 150,000 meals are served annually to just over 1,000 people a week during the summer. But in the bleak, lightless winter months, only around 200 stay, most of them engineers and maintenance staff, rather than scientists and explorers. Once a year, the station receives a huge shipment from the U.S. Coast Guard of more than 5 million kilograms worth of supplies, from heavy machinery and replacement infrastructure to medical aids and dried food. The rest is flown in when conditions allow, often along with scientists wishing to study the unique continent for themselves. Antarctic research at McMurdo covers everything from the continent's geology and biology to its glaciology and climatology. Its location on the McMurdo Sound, a natural harbor and the most southerly possible body of water in the world, puts it within reach of several key locations for active Antarctic research. Perhaps the most striking is Mount Erebus, the southernmost active volcano on Earth. Standing 3,800 meters tall, it is one of few active volcanoes left in Antarctica, bubbling away with one of Earth's only persistent lava lakes at its summit. Surrounding it are 3 extinct volcanoes, including Mount Terror, some 3,200 meters tall. Both are named after ships on Sir James Clark Ross' expedition to discover Ross Island in 1841. On the other side of the alien environments in Antarctica McMurdo Sound, we find one of the most extreme environments on Earth, the McMurdo Dry Valleys, a row of mountain valleys to the west of the Transantarctic Range, which are largely sheltered from wind and moisture billowing up from the coasts. This puts them among the driest deserts on Earth, and one of the closest analogues we have to the sands of the planet Mars, which also endure extreme surface dryness, cold desert conditions, and heightened UV radiation. As such, the survival strategies employed by the scarce few extremophile microbes that live here make intriguing templates for astrobiologists wishing to determine the kind of life that may once have existed on the Red Planet. Elsewhere in Antarctica lie a number of other equally alien environments, which offer windows into the conditions of our neighboring worlds. Within the depth of the East Antarctic Desert, the French-Italian-operated Concordia station, nicknamed Dome C, is used by the European Space Agency for astronaut endurance training. As one of the coldest, most exposed locations on the planet, it is a natural simulator of the conditions endured on long-haul space flights, providing an optimized earthly training center for studying adaptation to the extreme isolation and its effects on sleep cycles, mood, and immunity. On a more regular basis, the station drills for ice cores, aiming to shed light on more than 1 million years' worth of pristinely preserved climate history. Antarctica is also a great place to study meteorites. They litter its plains and are distinctive and well-preserved. One of particular interest was discovered in 1984, Allen Hills 84001, an ancient 4 billion-year-old meteorite believed to have originated from Mars. In 1996, a team of scientists highlighted unusual markings in the object, which they claimed resembled the imprints of fossilized microbes in rocks here on Earth. The idea that such an old yet life-bearing meteorite could have reached us from Mars briefly sparked a worldwide frenzy that even drew acknowledgement from then U.S. President Bill Clinton. Unfortunately, however, more rigorous analysis and scrutinization in the years since has largely ruled out the hypothesis, with the markings now better explained by non-biological processes. It's not just Mars analog environments that exist in Antarctica, either. Buried beneath more than 4 kilometers of ice at the heart of the Antarctic Plateau, we find Lake Vostok, the largest of Antarctica's 675 known subglacial lakes. It has been encased and shrouded from the atmosphere for several tens of millions of years, and any extremophile microbes that may cling to the underside of this sheet would make tangible blueprints for the kind of life we could expect beneath the shell of Europa, Jupiter's habitable oceanic moon. But buried so deep beneath the almost impenetrable icy surface of the plateau, Lake Vostok remains yet another Antarctic frontier lying just beyond the reach of our capabilities. And for the time being, at least, the eastern portion of the ice sheet is stable and will thus continue to conceal many of the continent's most tantalizing prehistoric treasures. The West Antarctic ice sheet, on the other hand, is considerably thinner, standing only a kilometer on average, rendering it much more sensitive and vulnerable to irreversible degradation, especially as global temperatures rise. In fact, West Antarctic researchers have already identified several notable instances of abnormal glacial retreat, with consequences spanning the entire continent, and perhaps even the rest of the world. The Thwaites Glacier is one of these Doomsday Glacier notable instances, often referred to as the weak underbelly of the West Antarctic ice sheet, which flows into a 45-kilometer wide shelf that acts as a natural dam. In 2022, scientists noticed a series of dramatic diagonal cracks spanning nearly the whole ice shelf, coinciding with an increase in glacial movement picked up by satellites. These factors suggest the Thwaites Shelf is disintegrating, threatening to shatter the structure as a whole in as little as the next decade. Already, meltwater from the Thwaites Glacier accounts for about 4% of global sea level rises, but the collapse of its ice shelf would triple the speed of this outflow, adding an additional 5%. If followed by the collapse of the entire glacier, something that may only be centuries away, then this alone would add more than 65 centimeters to sea levels worldwide. But what is even more worrisome is that these cracks have the potential to ricochet throughout much greater portions of the ice sheet. Already, warmer, saline seawater is starting to protrude the cracks in the Thwaites Shelf, allowing it to breach the underside of other, nearby glacier, with the potential to eventually undermine vast swathes of West Antarctica shelves. Simply put, if the Thwaites Glacier collapses as a result of these cracks, then much of the West Antarctic ice sheet is likely to follow suit in domino-like fashion. And while not quite the apocalyptic 50-meter rise in sea levels associated with the melting of the East Antarctic Plateau, the loss of West Antarctica would still add between 3 and 5 meters to global sea levels, causing all sorts of problems for coastal communities the world over. It just underlines the importance of insulating our fragile societies and ecosystems from the effect of an ever-changing world. As we've established today, Antarctica spent the majority of its history practically ice-free, and no matter what happens in the future, it will likely become so again. And on that wintry note, I bid you good night.